So come up with the prime factorization. So it's that tree, the tree, right? The factor tree. Break it down. Somebody joined. So let's see. Dale, was it? Dale, Rowan, or Tamia? Any one of you join? Let me know. Oh, Dale raised his hand, so it's your. Okay. You're not going to submit. I'm just going to ask you a question and you just answer there, so you don't have to submit your work per se. All right, we're going to do another one here, so I'm going to leave some space to go over that. Question 2. Determine the GCF of 90 and 660. And not guessing, but actually using the method we learned on Friday, okay? All right. Okay, so if you're still working, you can go ahead and finish the question. I'm gonna start going over the first two already. And there's a strategy that you can apply, right? It's not just one way of doing it, but I kind of stick to one method, and it kind of helps organize my thoughts a little bit. So finding what the number can be divided by, right? It can be identified right away knowing that this is an even number. But you can also add up the digits, right? 3 and 2 right? That's 5 and 4 is 9. So 3 goes into it as well, and 9 goes into it as well. I, though, stick to the fact that it's even because it kind of will make it so that it's an ascending order anyway. So I'm going to go 2 goes into it, and it's easier to divide as well, right? 2 goes into 3 one time. There's 12 left over. 2 goes in there 6 times. Nothing left over, so 2 goes into 4 2 times. So that's that. It's still even. So I'm going to go 2, right? Goes into 16 8 times, goes into 2 1 time. And then sometimes I break that rule. It's like, oh, 81, that's easy. That's 9 times 9. Right? And then I break those two down into 3 times 3 and 3 times 3. And now I have nothing but prime factors at the end. So you conclude saying 324. I asked you to write down the expanded form, but most likely, right, we will write down the short version of it with the powers. So it's 2 to the power of 2 times 3 to the power of 4. Okay, so there you have your prime factorization, but there's really nothing wrong with writing the expanded form of it. Okay, this is a bigger number, so I'm going to go even again. 2 goes in there once. There's 1 left over, so 18. 2 goes into 18 9 times. Nothing left over. 2 goes into 2 once. 2 goes into 2 another time, right? You have 19, 11, and then you're kind of stuck, right? You can't. This is not even, so 2 doesn't work. So let's add it up. 1 and 9 is 10. Plus 2 is 12. So you could get a 3 in there. Okay. So 3 goes into 19 6 times. There's 1 left over. Oops, sorry, what did I do here? 3 is a factor, right? 3 goes into 19 6 times. That's 18. That means 1 is left over, so bring down the 1. That's 11. 3 goes into 11 3 times. That leaves you with 21. Goes in there 7 times. Okay. Add it up again. 6 and 3 is 10, and 7 is 6 and 3 is 9, and 7 is 16. So the 3 doesn't work, right? So now you kind of gotta go through your list. You try 2, you try 3, 5 obviously will not work, right? Because it doesn't end in a 5. Now you have to try 7. Okay, that's the next highest in your prime factor list, right? So I'm gonna see if 7 first in my head, right? I'm just gonna go 7 goes into 63 9 times. Okay, yeah, it's gonna work, right? So 7 goes into 63 9 times, and into 7 1 time, right? And then you're stuck again, right? What would work here? And you're trying your next item in the list, right? You try 11. 11 doesn't work for sure. Then you're going to try 13, right? 13 goes in there. Does it? Does it not? You try, right? So if you go times 7, 13 times 7, you know that you're going to get a 1 there, right? So either you put 13 here and try times 7. So 3 times 7 is 21, right? You can do that on the side here. 13 times 7 if you want. 7 times 3 is 21. 1 times 7 is 7 plus 2 is 9, right? So you've double checked there. So it's 7 here as well. And yes, it's not quite an order, but then we conclude that 3,822 is 2 times 3 times 7 squared, because there's a 7 there and a 7 there, times 13. Okay, so this one was a little bit more challenging, right? When it gets to the numbers you don't recognize, right? That's where practice comes in, because then you will start to recognize those. Okay, so that's the answer to 1A and B. To find the GCFs, you need to do the prime factorization of both. Okay, so here you get a little looser, right? Like 9 times 10, you break this one down into 3 times 3, you break this one down into 2 times 5. Right? That's another way of doing it. So when it's numbers you recognize, it goes a little faster, right? So 90 is going to be 2 times 3 times 3 times 5. Okay? So we want it, when we're doing the GCF, you want to write it in expanded form. You don't want the powers. Then at 660, you can break that down to the 66 times 10. Right? This is going to be 6 times 11. This is going to be 2 times 5. It's already prime. The only one you need to still break down is the 6, which is 2 times 3. So prime, 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 right? So 660, you write it next to it. So I could give you more numbers to find a GCF for. So you just go lowest to highest in expanded form. So it's 2 times 2 times 3 times 5 times 11, right? 1, 2, 3, 4, 5 factors lined up here from smallest to greatest. Circle the common ones, right? 2 and 2 here. There's a 3 and a 3, 5 and a 5. So these are the sets that the factors that they share in common. So the GCF, this is the official way of writing it, by the way. GCF of these two numbers is going to be 2 times 3 times 5. Right? So this is 6 times 5 is 30, which you probably, I can see a few of you, if not all of you, probably having guessed that right away just by looking at the numbers. But don't do that, because you're going to be in trouble. I'm going to put tricky ones in there where you will not be able to guess. You'll have to resort to doing this. In fact, you always show your work no matter what. Okay, guess and check is not going to get you by. Okay, so write an expanded form. Right, when it's GCF, you want to write an expanded form like this, and possibly stack them like this. Right, that's the best way I find that you can do this with. Okay. All right, we're going to continue, kind of finish off this section. And we're going to probably go into section 3.2 already as well. So you will have seen GCF and LCM. GCF for sure twice, right? And the warm-up should have helped you remember, especially after a long weekend. I always find doing a little bit of a warm-up helps. Okay, so this is kind of wedged in between your notes. Then we continue here, multiples. If you are taking notes elsewhere, take those notes and continue, right? But I just included this as part of my notes. Multiples, examples of multiples, you'll need to know this, right? Multiples of 4, let's say. What that means is starting with 4, you're going to go up by 4. So 4, 8, 12, 16, 20, and the list goes on and on. Okay, so you should be familiar with that, right? The least common multiple and we will call that LCM, okay, of two or more numbers is the smallest number that is divisible by each number. And this is a bit complicated if you just go by the definition. So we're going to give you a short example, right? Example, the LCM of 3 and 4, right? You go multiples of 3 and then multiples of 4. You line them up like this, and then you start stating them. Multiples of 3 will be 3, 6, 9, 12, 15, and this would go on and on and on. You do the same thing with 4. 4, 8, 12, 16, and it keeps going. But I stopped there because I found the number, the smallest number, right? The smallest number where both 3 and 4 fit into, or 12 can be divided by both 3 and 4. Okay, that's what the least, this is the LCM right here, is 12. This is a visual representation of what we're about to do here. Give folks at home a few extra seconds. Catch up. And again, I could ask you to find the LCM of 3, 4, and 6, for example, right? Or 9, 3, 4, and 9. And we would have to just continue for all three. We would have to continue with the multiples until we find a value that they all share in common. Okay? So, find the LCM of 18, 20, and 30 using prime factorization. Step 1, write the prime factorization for each of the numbers. I want to get my terminology right. With the power form, use powers. So for LCM, you want to use powers. It's going to make it easier. So let's go ahead and I use small numbers for this to aid in the faster note taking, right? So you've got 18, 20, and 30. Those are the three numbers involved that you're trying to find the LCM for. So let's break it down, right? This could be 3 times 6 or 2 times 9, yes, right? And this is 2 times 3. Then we break down the next one. You go 2 times 10 or 4 times 5. It's up to you, and the 4 is still a composite. Remember, whichever number isn't a prime is called a composite. Okay. 30, you can go 5 times 6. So when it's smaller numbers, it's just random the way I do it. I don't necessarily go 2 first and then 3. I just break it down whichever way works. And so we get this, right? 18 is equal to 2 times 3 squared. Okay. 20 is equal to 2 squared times 5, right? Because there's 2 squared times 5. 30 is 2 times 3 times 5. So we first find the prime factors, then write it as each number as the prime factorization of it using the power form. And I will write step 2 here. Step 2, circle or identify the greatest power of each prime factor involved among all the lists. And I kind of call this a contest. Okay. So you're almost going through all the prime factors involved, and you pick the highest power of each. It doesn't matter, listen carefully, it doesn't matter if it's being shared by other numbers, okay? So you've got your three composite numbers and their prime factorization. You look at the 2 in particular. The highest power is 2 squared, okay? And you're comparing among all the lists, right? The next would be 3, right? 3 is the next highest in my prime factor list, and there's no 3 for 20, correct? Don't worry about it. Just look at the 3 in general. There's 3 to the power of 1 here, 3 squared there. So that's the highest power of 3 is found right here. And then you look at 5, right? And in this case, it really wouldn't matter which one you pick because 5 to the power of 1 is the highest power. So just pick one of them, okay? There's no 7, there's no 11, so don't worry about those. Out of the ones that appear, so this step 3, so step 2, we've identified the highest power of each prime factor that appears in one shape or form, okay? So step 3 is multiply circled numbers, and that's just like the GCF, right? So the LCM of 18, 20, and 30 is going to be 2 squared times 3 squared times 5. And this is where some mental math, right? 2 squared is 4, 3 squared is 9, and 5, right? So it's up to you how you want to do it. I would go 4 times 5, which is 20. 20 times 9 is 180, right? So that is the LCM. So if you were to write out the multiples of 18, 20, and 30, you keep writing them out. It's 180 where you would, that's the first time that all three would have the same value appear, okay? So let's mix it up now. We've done LCM and GCF. So what if I were to ask you find the GCF and the LCM of the numbers? So let's practice that. Mixing it up, right? Example, find the GCF, greatest common factor, and the LCM for 18 and 42. For 18 and 42. So regardless if it's GCF LCM, the first step is still finding the prime factorization for both. You can't get away from that. So let's go ahead and do that. 18, right? That's 2 times 9, and then 3 times 3. I think I did it differently earlier, right? I went 3 times 6. Now I go 2 times 9. So that's, I do that on purpose. And then we've got 48, 42, I mean, sorry. I'm going to do that underneath here. And then find the LCM and GCF here. Right? It's even. You go 7 times 6 or 6 times 7 if you want, right? 6 times 7 or 2 times 21. It's up to you. And this breaks down to 2 times 3. Sorry, I'm not going to do the dot there, just 2, 3. So it's 2, 3, 7. They're all prime. Okay. So to find the GCF, you write it in expanded form. Okay. So we go 18 is equal to 2 times 3 times 3. 42 is equal to 2 times 3 times 7. And they share the 2. They share the 3. And that's it. So the GCF is going to be 2 times 3, which is 6. LCM, power form, and you've got 18 is equal to 2 times 3 squared. 42 is equal to 2 times 3 times 7. You can't do it on a different way, right? There's only one of each. And remember, it's a contest. So 2 shows up. What's the biggest power of 2? It's 1. So it's really up to you which one you circle. Okay. 3 shows up. 3 to the power of 2 has the highest power, so you circle that one. 7 shows up. There's only one 7, so you circle it because that's the highest power. 7 to the 1 is the highest power of that prime factor. So the LCM is going to be 2 times 3 squared times 7. Okay, which ends up being 2 times 9 times 7. So 9 times 7 is 63. Times 2 is 120. 126. So the LCM is 126. So I'm going to talk about word problems here. How could this find its way into a word problem, right? So I'm just going to make up something here. So let's say, there are two students. The first student, how could we, pays for a lunch, like a monthly lunch pass every 18 days. The other one pays every 42 days, right? After how many days will they both pay at the same time, right? And the answer is after 126 days, right? If they both started on the same day paying, it would take 126 days until they both are paying at the same time for that lunch pass, if there is something offered like that, okay? So word problems, I might take some time later to go over them, but if I assign a question on that, then you're basically asking to find the GCF or LCM. It depends on the wording. GCF is more grouping type, like you're trying to group things together. LCM is usually the bigger number, and it's going to be under a scenario that I just described, okay? Now let's keep going here. So I'm going to leave the word problems, okay? The homework for this, I already gave you some homework, which you use this booklet, right? Use that booklet as your textbook, and the answers are at the back, okay? Don't forget that they're handwritten at the back. I already gave you some questions to do the other day on Friday. So I think I might repeat myself here, but 3.1, page 140. If I repeat myself, just don't worry about it, right? 3, 4, 5, 5 just do ADF, 6 do AE, you can do 7, 8 AE, so you only do A and E there, right? You don't have to do all of 8. 10 AE, 11 AC, 12 to 14. I'm just going to check if that's let's just do 13. 13 is a word problem. So WP means word problem, okay? So give that one a try. And so this concludes 3.1. I want to start 3.2 already. And so we're going to spend 20 minutes today and then all of tomorrow on that, but then at least you have a head start on that. So I'm going to stop this recording, and so if you see 2 videos, then that's